Hello everyone, welcome back to my channel. So in this video we'll see some of the problems regarding residues. Okay, so how to find the residues of a function if a function is given for you. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So about residues, I have explained you clearly the formulae in my previous video. So if you have not seen that, I'm providing the playlist link in the description, so please go there and see the video of the formulae. Okay, so I have done a video only on formula for residues. Okay, so see there and come back here in order to solve these problems. Right, so this is the function given for you. If you observe here, so z is equal to 1 is pole of order 3. Z is equal to 1 is a pole of order 3. So if you have a pole of order m at z is equal to z0, then what is the residue formula? Residue of f of z at z is equal to z0 is 1 by m minus 1 factorial into limit as z tends to z0 d power m minus 1 by dz power m minus 1 into z minus z0 whole cube into whole to the power of m into f of z. Okay, whole to the power of m into f of z. So now we have m is equal to 3 because it is a pole of order 3. Right, m is equal to 3 and z0 is equal to 1 we have. So substituting that residue of the given function f of z, this total is, I'm taking it as f of z. So residue of f of z at z is equal to 1. Okay, z0 value is 1 is 1 by 3 minus 1 factorial into limit as z tends to 1 d square by dz square of z minus z0. Okay, z minus z0 is 1. Okay, so z minus 1 whole cube into f of z. F of z is z e power z by z minus 1 whole cube. So this and this gets cancelled off, right? So 1 by 2 limit as z tends to 1 d square by dz square of z into e power z. Okay, so d by dz of z into e power z. So this is what we want, right? So d by dz of, so once you differentiate, this is uv form, this is u and this is v, so it is u dash v plus v dash u. Okay, d by dx of uv is u dash v plus v dash u. U dash means 1 into e power z, because dou by dou z of z is 1. So u dash v plus v dash is e power z into u is z. Okay, so this is d by dz of e power z plus z into e power z. And again if you do the differentiation, so this is d by dz of e power z plus d by dz of z into e power z. So d by dz of e power z is e power z plus again uv rule. Okay, again uv rule, so this is u and this is v again. So u dash v is e power z plus v dash u is z into e power z. So it will be 2 e power z plus z into e power z. So this is d square by dz square of z into e power z. So I'm substituting this here, okay, in this place. Right, so residue of f of z at z is equal to 1 is equal to 1 by 2 limit as z tends to 1. So in the place of this I'm substituting with 2 e power z plus z e power z. Now substituting the limit as z tends to 1, so this becomes 2 into e power 1 plus 1 into e power 1. So it is 2e plus e by 2, so it is 3e by 2. Okay, so this is how we can find the pole. First of all we have to find the pole and then we can find the residue. Okay, so this is the procedure to find the residue of of a given function which is having a pole of order m. Okay, right, we'll see the next problem. Okay, so find the residue at z is equal to 0 for the function. So they may ask you to find the poles and then find its corresponding residues, or they may ask you to find the residue at a given point like this. Okay, so these are the two methods they can ask on residue finding, right? So we have to find the residue of f of z at z is equal to 0. So simple pole formula is given by, so first of all we'll write the formula. At simple pole z tends to z0 is given by z minus z0, z minus z0 into is equal to limit as z tends to z0 into z minus z0 into f of z. So now in this question z0 is equal to 0 and f of z is equal to 1 plus e power z by sin z plus z cos z. Okay, so residue of f of z at z is equal to 0 is limit as z tends to limit as z tends to 0 z minus 0. So this is z minus z0, so z0 is 0, so you'll get z only, into 1 plus e power z divided by sin z plus z cos z. Okay, so if you substitute the limit directly, you'll get 0 by 0 form, right? So we can't get the residue because 0 by 0 form is indeterminate form. So divide this z which is in the numerator, I am sending it to denominator. So how can we write this? Limit as z tends to 0, 1 plus e power z divided by sin z plus z cos z divided by z. So can we write like this? So again z goes to numerator, it will have the same form this. Okay, so limit as z tends to 0, 1 plus e power z, 1 plus e power z divided by sin z divided by z plus z cos z divided by z is cos z. Okay, so z gets cancelled and you'll get only cos z here. Right, so applying the limits, limit as z tends to 0, 1 plus e power z divided by, applying the limits to each and every function, right? So sin z divided by z plus limit as z tends to 0 cos z. Okay, so we know that limit as z tends to 0 sin z by z is equal to 1. Okay, so it is not again a new concept. So when you substitute 0, you'll get a 0 by 0 form. So again taking L'Hospital rule, so taking the differentiation of numerator and denominator. So d by dz of sin z is cos z divided by d by dz of z is 1. So if you substitute the limit, that is 0, so this is from L'Hospital rule. Right, so when you substitute z is equal to 0, you'll get cos 0 which is equal to 1. So always remember this result. Okay, limit as z tends to 0, sin z by z is equal to 1. So when you substitute z is equal to 0 in the numerator, so you'll get 1 plus e power 0 divided by this total value, limit as z tends to 0, sin z by z is equal to 1. And when you substitute z is equal to 0 in this, you'll get cos 0. So 1 plus e power 0 is 2, so 1 plus 1, you'll get 2 by 1 plus 1, here also you'll get 2, so 2 by 2 which is equal to 1. Okay, so therefore residue of the given function at z is equal to 0 is 1. Okay, so this is how we can find a residue at a given value. Okay, so he has specified that to find the residue at z is equal to 0. Okay, right, next we'll solve one more problem, right, regarding the same concept, right? So find the residue of f of z at z is equal to 1 he is asking. So we know that z is equal to 1 is a pole of order 4. Okay, so if you have a pole of order m, what is the formula for residue? Residue of f of z at z is equal to z naught is equal to 1 by m minus 1 factorial, that is 1 by 4 minus 1 factorial, that is 3 factorial d cube by dz cube of z minus z naught, that is z minus 1 whole to the power of 4 into f of z. F of z is z cube by z minus 1 whole to the power of 4 into z minus 2 into z minus 3. Okay, so z minus 1 whole to the power of 4, z minus 1 whole to the power of 4 gets cancelled out. So you'll get 1 by 3 factorial into d cube by dz cube of z cube by z minus 2 into z minus 3. Okay, so solving by using UV rule is somewhat tedious. Okay, so normal solving is very difficult. So what we will do is we'll convert this into partial fractions. So direct conversion of partial fractions is not possible because this is an improper fraction. This is an improper fraction, that is degree of numerator is greater than degree of denominator. When degree of numerator is greater than denominator, then it is called improper fraction. So first this improper fraction has to be converted into proper fraction by using long division method. So z square minus 5z plus 6, that is denominator I have taken. Okay, multiply this, so z into z is z square, minus 3z minus 2z is minus 5z, minus 2 into minus 3 is plus 6. Okay, z cube, I am dividing with z cube. Right, z is the first thing, so it will get z cube minus 5z square plus 6. So this is minus plus minus, so that this will be cancelled off. So you'll get 5z square minus 6z, sorry, minus 6z. So again plus 5, so you'll get 5z square minus 25z. This 5z multiplied by minus 5z is minus 25z. 5 multiplied by 6 is plus 30. So this is minus, this is plus, this is minus. So you'll get 19z minus 30. So this is the remainder. Okay, so this z cube divided by z minus 2 into z minus 3. So this one. Okay, this is what we have taken, right? So this can be written as quotient first. So z plus 5 plus remainder 19z minus 30. 19z minus 30 divided by z square minus 5z plus 6. So if you observe here, this is the highest power here is 1 and the highest power here is 2. That is degree of denominator is more than degree of numerator. So it is a proper fraction. Now we can perform the partial fractions. So I am taking this 19z minus 30 divided by z minus 3 into z minus 2. So a by z minus 3 plus b by z minus 2. So a is obtained by just substituting z is equal to 3 by not taking this term. Okay, so 19 into 3 minus 30 divided by 3 minus 2 is 1. Okay, so this is 57 minus 30, which is equal to 27. Next b is equal to just substitute z is equal to 2 by not taking this term. So 19 into 2 minus 30 divided by 2 minus 3. This is minus 8. So z cube by z minus 2 into z minus 3 can be written as z plus 5 plus 27 by z minus 3 minus 8 by z minus 2. Okay, so we don't need this, but we need the triple differentiation of this. Okay, so 3 times you have to differentiate. Okay, because we have stopped here, right? So we need triple differentiation of this. So sorry, here limit as z tends to 1. I have forgot this. Okay, limit as z tends to 1 will be there. Right, so z plus 5. So I am differentiating first time. Okay, so first time differentiating this, that is d by dz of this value. I'm differentiating first time. So d by dz of z is 1 plus d by dz of 5 is 0 because it is a constant, and 27 into d by dz of 1 by z is minus 1 by z square, minus 1 by z minus 3 whole square, minus 8 into minus 1 by z minus 2 whole square. Okay, so this becomes 1 minus 27 by z minus 3 whole square plus 8 by z minus 2 whole square. Now differentiating again for the second time. Alright, so d by dz of 1 by z square is d by dz of 1 by z square is minus 2 by z cube. So using this 1, so d by dz of 1 is 0. Okay, next minus 27 into d by dz of 1 by z square form only, 1 by z minus 3 whole square, so it is of 1 by z square, so it will be minus 2 by z minus 3 whole cube. Okay, plus 8 into minus 2 by z minus 2 whole cube. Okay, using this formula. So now it becomes 54 by z minus 3 whole cube minus 16 by z minus 2 whole cube. Now again differentiating for the third time. Okay, so differentiating for the third time, so what you'll get, d by dz of 1 by z cube, d by dz of 1 by z cube is minus 3 by z to the power of 4, minus 3 by z to the power of 4. Okay, so 54 into minus 3 by z minus 3 whole to the power of 4 minus 16 into minus 3 by z minus 2 whole to the power of 4. So it becomes now 16 3s of 48, 48 by z minus 2 whole to the power of 4 minus 54 into 3 is 162. 162 divided by z minus 3 whole to the power of 4. So this is f triple dash of z. So what we need is at z is equal to 1. So limit as z tends to 1, d cube by dz cube of z cube by z minus 2 into z minus 3. So this value multiplied by 1 by 3 factorial is your residue, residue of f of z at z is equal to 1. So 1 by 6, 3 factorial is 6. Okay, so this total d cube by dz cube, okay, so is this one 48. Okay, 48 by z minus 2 whole to the power of 4 minus 162 by z minus 3 whole to the power of 4. So if you substitute z is equal to 1, so what you will get, 48 by 1 minus 2, right? 1 minus 2 is minus 1, so minus 1 whole to the power of 4 minus 162 by 1 minus 3, that is minus 2 whole to the power of 4. So 1 by 6 into 48 minus 1 whole to the power of 4 is 1 only, so by minus 162 by 16. Okay, 162 by 16. So if you solve, you will get 101 by 16. Okay, so that is your answer. Okay, so very long procedure, but you should be aware of this type also, right? So if an improper fraction is given like this, that is if the numerator power, here numerator power is 3, so numerator power is 3, but denominator power is 4 plus 1 5 plus 1 6, so numerator power is 6, denominator power is 6. Even though it is a proper fraction, but when you solve for residue, so you are getting an improper fraction like this. Okay, so improper fraction like this. So once you got improper fraction, it is difficult to do u by v rule. Okay, so it is difficult to do u by v rule. Instead you can learn the procedure like this. Okay.